So lesson 10.5, sine and cosine. I've got you in a different spot. Attendance. Okay, sine and cosine. Sine and cosine are kind of like the tangent, where you're using certain sides of the triangle to make a fraction, but it's not opposite and adjacent. It's a different combination. Sine is comparing the leg opposite of the angle to the hypotenuse. That's kind of weird how that angle symbol is down a little bit lower. Leg opposite angle A to the hypotenuse, and the cosine is the leg adjacent to angle A compared to the hypotenuse. Today, sine is opposite leg over hypotenuse. Cosine is adjacent leg over hypotenuse. So we'll do some of the same things today with sine and cosine as we did yesterday. Take a look at the table, your calculators, and then finally use them to solve in the triangles. Probably won't take quite as long because you kind of know what's going on. So let's first pull a triangle. Well, we've got a tall, skinny one on my screen here. So let's put some numbers on here. And I think something like 7, 24, and 25 makes the right triangle. Let's call this top angle, angle A for right now. Okay, so what would the sine of angle A be from my pictured triangle? Can you, yep, raise hands a little bit, Shay? 7 over 25. So from A, 7 would be the leg that's opposite, and the 25 is the hypotenuse. See where the right angle is. So 7 over 25 is the sine of angle A. How about the cosine of angle A? The leg that's adjacent to A compared to the hypotenuse. Colson? 24 over 25. Right. So same terminology, opposite, adjacent, and hypotenuse, but yesterday we didn't use the hypotenuse at all. Today we need the hypotenuse. Can you see at the bottom there? Before we leave that screen, any clarifying questions? Okay, while some are finishing their notes there, I'm going to continue on. They don't have to worry about doing this part. What if I used angle B instead of angle A? What would the sine of B be? How much? Which one? Sine is opposite leg. So what leg's opposite of B? 24 over hypotenuse. 25. Cosine of B, what leg is adjacent to angle B? 7, and the 25 is the hypotenuse still. If you look at the blue and the red, you might notice that the sine of A is the cosine of B. 7/25. And the cosine of A is the same as the sine of B. Those values do duplicate, just depends which angle you're looking at. Okay, we're going on to a different triangle. Oh, little memory phrase. I had it written up from last period, but the little memory phrase, SOHCAHTOA, would be a way to remember yesterday and today what sine, cosine, and tangent are. So the little memory phrase, just write down SOHCAHTOA, and then let me explain what SOHCAHTOA is. It's kind of the key to the notes from yesterday and today. Okay, the SOH, SOA, means sine is opposite over hypotenuse. The COA, or SOHCA, cosine, is adjacent over hypotenuse. And then TOA, tangent, is opposite over adjacent. So that little phrase tells you what trig ratio and what the sides are that you make in the fraction. So that's kind of your key to learning this part of geometry. So I would suggest that you write that on the top of your paper for the next few days while you're doing lessons that are based on the trig ratios. So I've got most of that on the board here, but I didn't put it in the right order. I'll put tangent down below here. Tangent is opposite leg over adjacent leg. So up at the top of this information, I'll put SOHCAHTOA. If you don't spell SOHCAHTOA right, it throws everything off, of course. All right, let's do some example type things. Find the sine and the cosine values. What do I mean by values? What was our book having us do? Fraction and put it in decimal, 4 places. All right, so let's use a 6, 8, 10 triangle, and I'll go with A down here. I want you to find the sine of angle A and then the cosine of angle A. So fraction reduced and decimal. Okay, work on those two. What side over what side? Sine is opposite leg over hypotenuse. Go from angle A, which leg is opposite, and what's the hypotenuse? Fraction and decimal. Angle A, opposite would not be, yeah, this is, so I got it backwards. Yep. Mm-hmm. Okay, sine was 6 over 10. If you reduced it, it was 3 over 5. And in decimal was 0.6. If it said to 4 decimal places, you'd fill in zeros. Cosine of A, 8 over 10. Maybe you reduced it, 4 over 5. Decimal was 0.8. Question on that one? No? Okay, let's erase those numbers and do another one. We'll switch to the other angle, but give you some different numbers too. Let's go with 12, 16, and 20. And we'll call this angle the one that we're interested in. So do the sine the cosine of angle B. Okay. Sine. Sine would have been 16 over 20, 8 over 10, 4 over 5, and the decimal was 0.8. Cosine was 12 over 20, or 6 over 10, or 3 over 5, 0.6. Any question on those? Okay, then yesterday, the next thing we did was that table in the back of the book. Let's take a quick look there. From the table on page 705, you remember there's a sine column, a cosine column, and a tangent column. Got to make sure you're reading the correct column. I want you to find what is the sine of 38 degrees. Make sure you're reading the sine column. Open.
0.6157.
I think that was correct. Okay, let's find the sine of 72 degrees. Tara, what'd you find? Correct. Cosine of 58 degrees. Cosine. Cody, what you got? Didn't look, is that right? Yeah. Okay, and then cosine of, let's go real small, 14 degrees. Jaden? Okay. So as you're reading that table, if you're having to use that because you don't have a calculator with those sine, cosine, tangent on them, make sure you're in the correct column. Okay, grab your calculator, see if you can get those same values. Are you using the sine button or the cosine button? See this RAD? Yep, it's in radians. Yes. Okay. Now your calculator has to be in degrees in order for those numbers to match up correctly. Allie's found, well, Allie's had just a mode button, degree button, so it just depends. Yeah, as long as it's in degrees, you're good. Okay, anybody having trouble getting the values? Okay. And going to 4 decimal places, remember that if you are rounding to 4 decimal places. 1, 2, 3, 4. If I want to go to 4 decimal places, I have to look at the fifth and decide if it's causing me to round up or not. With this being a 7, that means I have to round up. So instead of 0.0423, you're going to go 0.0424. So round correctly. Sound like someone did 3 places on their homework. Go 4, but look at the fifth. Okay, so let's use this sine and cosine, not just tangent, to find sides of the triangle. Okay, so let's set up, we're going to try and find this side. The hypotenuse is 28 centimeters. And let's go with this angle down here as being 17 degrees. That's very close to what we were doing yesterday, but it's not always tangent. We have to figure out how do you know whether it's tangent, whether it's sine, or whether it's cosine. Depends what sides you're using. Okay? The side that we want, if I use the 17-degree angle, the one I'm looking for is the opposite leg. The one that I know is hypotenuse. So now we have to look. If I use tangent, now I need an opposite and adjacent. I need opposite and hypotenuse. Right here. So I would use, instead of tangent, I'm going to use sine. So what you will write down is, instead of tangent, you're using sine. So sine of 17 degrees over 1, let's write down what we're doing, equals opposite is x over hypotenuse, which is 28. And you're going to write that on every problem when you're trying to find a missing piece of information. Got the answer? Okay, you took 28 times the sine of 17. Okay, Colton, let's see if they agree with you. To the nearest tenth. How many places is tenths? Should be 1 decimal, so look at the second decimal. Something doesn't look right?
It must be
186. So 8.2 is what it sounds like.
Yeah.
Okay, is he rounding correctly for me? Okay, 8.2 centimeters. Question on deciding sine? Okay, let's change the problem. Okay, let's say this angle we know is 70 degrees. Let's still put the x there, and let's still keep 28 centimeters for the hypotenuse. Let's decide if we would use sine, cosine, or tangent. Which side are we looking for? Okay, adjacent is what we're looking for if we use the 70. And which side do we know? Hypotenuse. So adjacent and hypotenuse. Cosine this time. So write down cosine, C-O-S. Cosine of 70 degrees over 1 equals x over 28. Times cosine is 70. Since you guys are using all my calculators, I can't do these with you. Alex? 9.6? Question on that one? No? Okay, let's make another one. Okay, am I leaving you enough time to write it down? Okay. Let's put the angle as 29 degrees. Let's try and find the hypotenuse this time. And this side is 12 inches. Think about what those sides are. The side I'm looking for is the hypotenuse. The side I know is opposite. So which trig ratio has hypotenuse and opposite? Sine. Okay, so write down that you're using sine. What angle? 29 degrees, so sine of 29. If you put the degree symbol, it might help you remember that it is the angle that you have to put there. Sine of 29 degrees over 1 equals what fraction? Does the x go in the bottom or the top?
X goes in the bottom.
Bottom this time because the hypotenuse is what the x is. So 12 is opposite, x is the hypotenuse. So cross multiplying, x times the sine of 29 equals 12 times 1. So for this one you have to divide,
Divide
not divide sine by,
sine. Divide 12 by sine.
right, divide 12 by the sine of 29. And what do we get for the length of the hypotenuse? 0.5?
24.6. 8.
24.8 is what it's approximately when you rounded it. And that was inches. And I can look and say, is that logical for x to be so much bigger? Well, it's the hypotenuse. So it is supposed to be bigger than what the leg is. Okay, question? Carrie, you making sense out of it? Okay. Michael, you good? Who else was gone yesterday? Anybody else? Okay, but you getting a nice mark. Okay, was there a question? Okay. All right, I think that I was just leaving it open. I'm going to draw the triangle different positions now. We'll do just a few more and then that's what sine cosine is about. Okay, let's make this a 68-degree angle. Let's figure out the hypotenuse and which leg you want me to give you. The bottom one? Okay, that is 12 inches again. Figure out if it's sine, cosine, or tangent. Jaden, are we going to use sine, cosine, or tangent? Sine, are we going to use sine, cosine, or tangent? Correct? Will you multiply them together? Not for what we're doing, but you know, this is just an introduction. There are some different properties and things that you would use in maybe trig, probably more pre-calculus that would involve putting them together. I guess in trig we do sometimes multiply the values together. So eventually, but not really for what we're doing. And what is 12 divided by the cosine of 68? 32.0 inches. Okay. Question? Anybody ask? Clarifying? Okay, and how about find that side. This side is 16.2 centimeters, and this is a 35-degree angle. Find what x is. Is this the way set up? You don't have the 12. I think I had the x on my we've decided on sine, so the opposite leg would go on the top. And then the hypotenuse has to go on the bottom, but we don't know the hypotenuse. It's not science now. I'm going to take a poll. How many use sine? How many use cosine? How many use tangent? Okay, we've got a few people using each one. Obviously, they're not all right. Well, let's see. Which one's the right one? From this angle, the thing we're looking for is opposite leg. And the thing we have is adjacent leg. So what trig ratio has both opposite and adjacent? Tangent. I pulled one from yesterday. Tangent this time, not sine or cosine. Because those are the two measurements that are involved in the problem. One we're looking for and one we know. So this one should have been tangent of 35 over 1 equals x over 16.2. Okay, so who solved it right can give me an answer. Lizzie, what'd you, 11.3? So x was 11.3 when you cross multiply. What would happen instead of that angle, what would be this angle up here in the same triangle? What's the other angle?
55 degrees.
55, using the triangle sum? Okay, what if I gave you that angle instead of the 35? How would that change the problem? Would it still be tangent?
Because you'd be looking for the opposite.
You're looking for, oh no. Wouldn't this be opposite
You
now?
would know the opposite, you'd be looking for the adjacent.
You would know the opposite, you're looking for the adjacent. Would it still be tangent?
Yeah.
Opposite and adjacent? Yeah. So we would still do tangent of 55. The fraction would be 16.2 over x.
Same answer.
Cross multiply. This one's just a little bit harder to solve because you have to divide. But take, 16.2 divided by the tangent of 55. Do you still get the 11.3?
Yes.
Yeah. So it really doesn't matter which acute angle you use. One is maybe going to be easier to solve than the other. And I think the ones that are easier to solve have the variable in the top instead of the variable in the bottom. So when you can decide which angle, you can pick which one ends up easiest. But it doesn't really matter which one you use. No, it really doesn't. So you're deciding which trig ratio based upon what side you're looking for and what side you have. All right, let's write down what our assignment on that is, and then we've got a quiz on mostly radicals. Let's see, Vicki, do you have those triangles? Vicki, are those triangles available for them in your room? Okay, page. Page 566. 1 to 3, 5 to 11, 13, 14, 17, through 32, 40 to 42. That should mostly be on sine and cosine. You'll probably want a calculator for your quiz. But there are problems that do not allow you to give me